Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video today is going to take a look at x86 assembly language as it relates to the Irvine library. So there's a lot of functionality here to go through, all the basics, and so let's get started with it. Before we get going with this specifically, what is the motivation for any library, right? Is so that we do not have to reinvent the wheel. This class, as I've been told many, many times, is difficult enough as it is, but if we had to reinvent every single function to, like input and output and just maintaining data and so forth, that this class would be exponentially even harder. And of course, our forefathers who invented and discovered and created all of this architecture, yes, they had to do that from scratch themselves. That's what makes everything so amazing, that we started with nothing and we were able to build ourselves to this point. But of course, now it's all been invented, so there's no reason, think of any language. There's no reason, if there's a library function to do the work, there's no reason not to use it, because it's been done before, and if it's in a library somewhere, it's been tested a heck of a lot more than your code will ever be tested. So that is where we're going with this. So the source code, like if you've ever wanted to see the source code for these kind of things, like random number generation and stuff like that, that is available. I mean, it's not the greatest random number generator, but it's really good for just a general use random number generator. And the code is available to you. And it's like, how does it work? I've always wondered, and I went to see, and it's pretty cool. So go ahead and do that if it's inside of the deliverable, at least my students, and you can go to Kip Irvine's website if you need to go get the source code otherwise. So, but the thing is, since this is very, very low level, there is no standard library, so that's why Irvine's library is it's great that it exists at all and that we can use it, because again, otherwise we'd have to create our own. But there is no standard like this. There is no standard template library or whatever. There's no for whatever language you can think of, there is no standard library. And so, of course, as much as it's complicated, because we have to get used to the APIs, we have to get used to what the Irvine library does for us, get used to like the inputs and outputs to it, how it works. But again, that is much simpler than having to reinvent and do this all ourselves. So as you could imagine, we're going to be doing this in Visual Studio, and I'm going to be describing this as we go. So the MASM project template is a great starting point. I already give that to you guys for for your classwork, so you don't have to really worry about getting all of that working on top of everything else. But as you could imagine, every function has different inputs, different requirements, different outputs. I mean, think about it, right? So like absolute value, one input, one output. Power function, 2 inputs, 1 output, and so forth and so on. And so depending on the language, some take references, some take pointers, some take values, some return things, some don't. You just have to get used to the way the functions work. And so that's just part of being a programmer, is just getting that experience, trying it out, and just hopefully remembering next time exactly how you used it the first time. And so this is the link to get you to his website that gives you better functionality. And I'm hearing rumors that it doesn't work. I'm not going to try it right now. But if it doesn't work, you can use the Wayback Machine or something like that to go find a previous time where this thing worked, and you can actually pull down the information you need to do. Okay, so simple stuff here. So here I have my Visual Studio, and this program runs and does nothing. I mean, I'm running everything in 2019. Visual Studio 2019, so this usually comes up no matter what I try to do now anyway. So, but if I want to put in a wait message, I just call wait message. And now I'll have to remember to drag this every single time. There is my press any key to continue. That's my system pause, basically equivalent to that. And so that's how you would do a wait message. Moving on to other functions, here's dump regs. Remember, of course, we have EAX, EBX, ECX, EDX, ESI, EDI, ESP, EBP. Those are the 8 general use registers. You have the instruction pointer, and then you have the status of the flags. And at any moment in time, I can call dump reg, sorry, and I can view this. And of course, every single time you do this, it's going to be different, because the computer, this CPU is running, how many different threads going on at the same time, and I would be freaked out if it did give me the same values. I think, hold on, okay, so is it giving me the same values? Oh, it is giving me the same values. That's kind of freaking me out. Every time I run this, I'm getting the same stuff. Oh, not everything. Some are the same, some are different. And again, it all, there's a lot going on under the hood. But when the program starts off, just like, a register is just a variable sitting on the CPU, they're basically uninitialized to us. They're just garbage. And that's why we have to start the program off by saying, okay, you're a 0 and you're a 3 and you're a 9. We're setting, initializing values for registers and variables before we can officially start the program, because basically we've been given the workspace, but otherwise that workspace is completely jumbled until we start making some order from it. So delaying, so I could set up a delay. Now this is where we can start using registers for the first time. So I say, okay, let's put a 2-second delay before I even show anything. And then afterwards, I'll do a 1-second delay. So this is how you would do something like that. So 2-second delay, put 2000 milliseconds in, call it, then call dump regs, then wait 1 more second to then show me the wait screen. This is pretty fast here. 1, 2, 1, there we go. So that's all there is to it. So this kind of stuff doesn't really exist too much, at least in C++. You can tie into other libraries, but this isn't part of any portable standard library from my understanding, but it works here for us, and that's perfectly good. So writing a number as a binary to the output, to the screen. So let me get rid of these delays and these dump regs and just start moving over into other things here. So it's like, okay, I need to put a value into the entire EAX register, so I'll put what number? This is just 30, no, so it's 18,423, whatever that is. And if I call write bin, or write bind, however you want to pronounce it, it will write everything out. And there it goes. So there's my number 18,000 in 32-bit binary on 32-bit. I was thinking 16-bit. So there's a lot of zeros here because I only need apparently 15 bits to represent this number in binary. And then notice, yep, here we go. So that this prints, and then it prints the wait message right after. And so I'm sure they'll be here in a second, but I can also do a call CRLF carriage return line feed to basically do the /n or the end line character, so that now it prints everything out, goes to the next line, and then does my wait message. And so but you have to remember, all of these things you have to remember, like in this EAX is the general register to use, but every function is going to be different. Write character. So this time I have to store something in the AL register, not the EAX register. Remember, AL is the 8-bit portion of the giant register. So if I want to put a question mark in here, I do something like this, call write character, and there's my question mark. And I could put, into EAX, I could do the entire EAX register. I believe it'll work, and if not, yep, I still can. But again, an ASCII character is an 8-bit quantity. It's a byte. And so the low end of the EAX register is the only thing that gets modified or gets used when the write character function is active and is called. So you can fill up everything with whatever you want, but in the EAX register, but only AL is the thing that matters. So now coming back, just writing the number in decimal format, put number 43 in here, call write des or dec, however you pronounce it, and this puts it in unsigned format. So negative or positive 43, but if I say let's try negative 43, then you see you get 4.29 billion because this is an unsigned quantity, 32-bit quantity, and that is an overflow or underflow or whatever you want to think about it. And that number is represented as negative 43 if you were supplying 2's complement, but since we're not, what we would have to do is set this up and use ReadInt instead, and now it will print negative 43 because now it's using signed. Is that next here? Yeah. Now it's using signed math. And then positive 43, you just have to understand that with this ReadInt function, in the Irvine library, that any positive value gets a leading plus sign. And if you don't like that, go write your own code. Or go tinker with the source code and create your own. But that is a little different than what we expect to see normally, but that's not a big deal there. So write string. Here's where things get a little more complicated now. So what I need to do is have a character array somewhere in data, somewhere in my data. So I can just say hello message, or just say hello, and I can use byte. Everything in ASCII is using byte format, so just always this, and you go hello everyone, exclamation point, and you have to remember the null terminating character, the 0 at the end of the string. And so what I can do now here is, now this is a little different. Now I have to move into the EDX register, the pointer to where the string is. Because again, it's just a character array, but so we have to know where to start. So I'm saying, okay, pass the pointer, give me the first byte in this hello everyone string. And so that goes into there, and then I can call wait message. Or I'm sorry, wait string. And so there's my hello everyone with the carriage return line feed and the wait message. And so if you forget the 0, you look at this and go, Brad, as always, you're just full of everything. And you go, yep, nothing changed. But I'm like, yeah, okay, fine. You got me on that one. But what if I go ahead and I put like hello 2 right after it, and that without nobody has any zeros, and you go, okay, now what happens is the program runs and goes, hello everyone, hello everyone. And you're like, well, what is happening is that it didn't hit the null terminating 0, and the data segment is crammed in as nicely and as closely as possible so that we can reduce the amount of size that our program needs to execute. So because there's no null terminating character here, it just keeps on going. And apparently the data segment puts a 0 at the end. That's the only thing I can guarantee, I can pretty much tell you, is because it doesn't keep going until it finds a 0. So there must be a 0 right after the everyone. And so to eliminate that, we do need the comma zeros to tell our programs that null termination character exists, and now I don't want to go past that character. Because there's no other way to do this. Because the 0 is what tells C++, and it tells assembly language also when the string ends. Because basically you're just asking, are you 0? Are you 0? And you just print the character to the console until you hear back that, yes, this is actually a 0 character. And you will see here that I'm not going to show everything. I'm just going to show you the important stuff to kind of get you going. And some of these like files and things like that, just to show you that they exist and you could work in binary mode with files if you so chose. But we're not necessarily going to cover that in this course. So ReadInt. So wouldn't it be nice if I could do something like, like give me a value, and I'll put it into a value, and then I'll parrot it back to you and just tell you exactly what you input. So I could put something like prompt byte enter number or value or whatever, doesn't much matter, comma 0, remember the comma 0, and then so just kind of starting to combine these things together. So I could say move into the EDX register the offset of prompt, and then I can call write string. I already did it, so I can put that there. So just baby goose steps here. There's enter number, and so now what I can do is just immediately call ReadInt. And so let's see, this reads a 32-bit signed decimal integer from input, stopping when enter key is pressed, all valid digits. Let's just presume everything happens as expected and the user puts in a correct value. Leading spaces are ignored and the optional plus or sign is permitted. So I can put a negative sign in here because it's a signed value. And what it does is returns into the EAX register whatever value was input from the user, which is very cool. So what I can do after that here is just to kind of finish this up here and call it result and say byte you entered, and put this with a comma 0. Okay, so I say okay, write the string, read the int, then print out the result string, and then EAX register already holds the result of this read int. So right, that's the whole point of this, and the EAX register has not been modified by either moving into EDX register or calling the write string, so I can go right ahead and just immediately call write int. And we haven't, say we got ReadInt, we haven't talked about WriteInt. Oh yeah, we have, of course we have. Or wait, have we? Yeah, of course we have. I was thinking for a moment we were going in alphabetical order, but we're not. So here we go. So enter a number, we're going to go 57, and it goes, okay, enter, and it goes, you entered positive 57, and that's exactly right. And if I do this one more time with a negative sign, negative 19, it comes back as you entered -19, which is exactly what I'm expecting to see. So my ReadInt function, and say, what happens if you put in just garbage? If I put in my name, Brad, invalid integer. So it's like, oh, that's not good. So yeah, so basically we don't have exception handling or anything like that in this library or anything close to it. So you get a printout, and then of course it returns a 0 because that's what it promises to do. Invalid input, EAX is set to 0. And so you know if the overflow flag gets set, you know if you screwed up. So I like this. You're getting, it's pretty simple, right? It's almost as simple as Python or any of those other kind of languages. So what Visual Studio is actually doing is basically booting up an old, if you want to think of an old DOS prompt shell, like a PowerShell, something like that, because you can do that right here. I can just put CMD in here and bring up the command prompt, and that's the console window. Basically, you're creating a console window and running the program through there, and that occurs in pretty much every language. It's bringing, at least when you're running on a Windows box, it's bringing up that command prompt and doing its work, even in Java and other languages. So that's what's happening to us. So the console window traditionally was an 80 column by 25 row system. So there was like 4,000 or 2,000 characters on the entire screen, and that's how things work. But in the last few years, Visual Studio has changed those dimensions. So I haven't seen this working perfectly with some of these functions that you'll see that I'm going to be showing you. But we can definitely do things we can't normally do without extra Windows libraries in like C++, like moving the cursor around and changing the text color and stuff like that. And so just be careful that some of the code you see might not 100% work with again with figuring out how many columns and rows the console windows and things like that. Those might not work. But clear screen, right? Like we can do that. So we can print this all out and like, okay, right after I do the ReadInt, I can call out and call clear screen. So enter number 7, and it goes, you entered +7, right? So there we go. So it cleared the screen before moving on. Simple stuff. CRLF we already showed, working it down here. It's basically just a new line character. And so you could put that into, that's the thing though, you have a new line character in assembly language is different than C++. The /n that we're used to seeing in pretty much every other high-level language is replaced with 2 separate characters. That's why it's carriage return and line feed. And so, it's ODH, so basically it's a 13 and a 10 are the 2 characters for carriage return line feed. And so just so you're aware of that's what this is doing in those cases. Go to XY, that's kind of cool, right? I can actually move the cursor on the screen. So if I say, okay, I'll move DL to 24, and I'll move DH to 9, go to XY, go to XY, and then do this, you will see now my program's moved over 24 to the right and 9 down before it even starts out. And I would say it doesn't format everything from there if I put an 8 in, because it continues off and basically brings everything back, the cursor, everything back to the top of the screen when I clear it. But you see there you have that +8 and everything's coming out. So I usually either do it exactly right or you do it exactly mirror imaged. DL is the column number and DH is the row number when it comes to this. Again, this is one of those functions that might not work exactly as you think. Get max XY, no reason to talk about it other than I'm just flinging through here, just finding out what functions I need to describe to you now. Here is a fun one, set text color. So there are 16 colors available to us when we're using this system. And so they all have names. You can actually use these names as colors. So they're part of the Irvine library. And so what you do is you notice it's 16 colors, that requires 4 bits of storage for a number between 0 and 15. And so to have 8, and then to have 8 bits of storage, 1 byte, what I can do is have 4 bits for the background color and 4 bits for the foreground color, essentially giving me 256 possible ways that I can have a foreground background combination. And so you just have to understand that since we're dealing with bits, you just kind of have to shift everything over. a little bit. So if I want, like you're saying, you see the example here, but let's just say I wanted to do red on a white background. I can do move into the EAX register, and I could say, okay, I just want to make sure the background color is what gets shifted over. So I could say I can do white times 16 plus red. And now everything else, oops, I didn't call the function. That's a common thing, right? I just did it. So you're like, why didn't it work? It's because you did all the hard work, but you didn't actually, you set up the parameters, but you never actually called the function. And so there we go. Now I have red text on a white background. Did I do that? Yep, white background, red text. And until I change anything, it's going to continue to do that. That's basically clear screen and everything. It is going to continue to be red on a white background until I change it back to what, basically if I just did this for this sake, I read the int, I clear the screen, or I do this before I clear the screen, and I can say, okay, of course, black background, white foreground, bring it back to normal. And so now I have red on white for my number, and then now there's my normal white on black. So text colors, pretty simple, pretty fun stuff. Randomize, let's talk about that. Okay, so random number generator is very similar to rand and some of those other functions that you're probably accustomed to. It just uses, probably not as well produced of a random number generator. I'm not trying to offend Mr. Irvine, just saying that I haven't done any research into it, but there are a lot of better random number generators than just your bare bones entry level algorithm. But randomize basically looks at the timer and the computer, what time is it, and sets a seed accordingly. Because otherwise, the program would run exactly the same. The random numbers would be generated the exact same every single time, because it's just a pseudo random number generator. It's not. There's very few things in this world that can generate true random values. And working in the casino industry for 5 years, I can tell you that enough people trying to find a way through that random number generator, because once you can break the system, you can make a ton of money. So random range is what you use to actually generate this. So if I wanted, let's just say I wanted to set up, and forgive me if we haven't covered this, but you'll see this soon enough. I say I want 10 random numbers. And so I can use a loop structure. And so the loop will get me again. And what I can do here is I can say, okay, move into EAX register 100, and then call random range. So this, every single time I call random range, will return me a random number in the range from 0 to 99. So it goes from 0 to n minus 1. So if I then go ahead and increment EAX, because EAX is where that value is stored, basically to bring me back, so that now it'll print a value between 1 and 100, right? 0 to 99, shift over 1, so now the value goes from 1 to 100. Now I can go ahead and call ReadInt, and then do my right character, just to set up a space between all the values. Otherwise, you might think that this is one giant long random number that was generated. So I can move a space and move into AL register a space, and then call right character. So look at that, right? All this cool stuff we're doing already. And so here we go. Every time, 76, 39, 74, so forth and so on. Every time I do this, I'm going to generate new results, because every single time I run this, I'm using the timer. And so if I comment this out, you'll see I get 95, 368, and if I run this again a second time, you'll see I get 95, 368, and so forth and so on. So that randomize is very important to, especially when you're done with development and you're ready to push this off into the real world and you want true randomization, put in this call randomize, so that now, your test code has been run, you're satisfied, and now you're ready to move on and let everyone else try the true random number generator that you've generated here. If you are interested in timing things, because timing is generally used when you're discussing algorithms, like which one's faster, And if you want to actually physically try to test it, you can use this getMSeconds function. And so this returns the number of milliseconds that have elapsed since midnight. And you're like, well, that gives me no use, but it's all a relative thing. If I set a timer and if I called this function when the program started, and then I let the program run, and then I called the function another time when the program has ended, now I have a beginning time and an end time, right? An elapsed time. Take the larger number and subtract off the smaller one, and you know how much time the function or whatever has taken, how much time has elapsed between the two time points. And so it's so you can use dword here, and you're like, okay, set things up, because the EAX register gets the return value, and this just stores this in a variable as opposed to a register or something like that. So as you can imagine, programs generally run very quickly. So a lot of times when you want to test this sort of stuff out to see if something's faster than another, you have to loop it like thousands of times to be able to get it to an appreciable amount where you can be like, oh, this one's faster than this one, because you're never going to notice. If this is in milliseconds, that you're never going to notice unless you're dealing with something that you can spread the time out so that you can have a noticeable difference between the two activities that you're trying to perform. You can figure out string length, and essentially the function just goes, are you 0, are you 0, are you 0, and just counts until it finds a 0. There's nothing complicated about that whatsoever. It's here for you if you need it. Is digit, basically checking to see if the ASCII value is between ASCII 0 and ASCII 9, true or false. We're used to returning things like in the EAX register in some way, but this function, according to Irvine, sets the 0 flag accordingly. So again, you just have to get used to other people's way of doing things. That might not necessarily be the way I would do things, because generally EAX should hold the result, but it's how he's doing it. I'd have to rewrite the code if I cared enough. So everything else before we get into more specific examples is just file handling. And again, I'm just going to just slosh through this and just say, yeah, I can do, this is C++ code, everything I can do in C++, as long as it's in binary mode, I can do in assembly language. And so text mode is different. There is no I don't know of any way to set up text mode, but you'd have to write it yourself, which is complicated enough, right? But just to say you can work in binary mode, and these functions, open file, read from file, create file as for output, write to file, close file, those are all the things you need, right? You need to open a file, process file, and close file. And and reading and writing are the ways that you process that file, right? So those basic activities, that basic functionality is here for you. So let's take a look at our examples here. So pretty much all the basic stuff that we're going to need has been covered. And if there's anything specific, you can always go back and find it or send me an email for questions. So something like this. We've already kind of covered some advanced stuff here. So let's say clear the console window, dump the registers, then delay for 2 seconds. We've already done this. This is like the first kind of thing we did. So what have I got? Clear the window using clear screen, then call dump regs, then put a 2-second delay in. We already did that right up front. Put 2000 into the EAX register and call delay. And so the output will be different every time, like we discussed, or pretty much different every time we run the program. And then it'll pause 2 seconds before the program ends. So that's example 1. So let's see, example 2 we've already covered as well. We've done this. Display a null terminated string to the console and then move the cursor to the next line. So hello world, string, hello world, comma 0. Remember that we need that comma 0 again. I proved why earlier. And so move into the EDX register, the offset, the pointer to the string I want to print, and then I can call the function. And then to move on to the next line, I have to call carriage return line feed. So that's example 2. Display a null terminated string which has a new line character embedded in it to the console window. So this one doesn't have the new line character in it, and so I have to call CRLF explicitly, but with this inside of it, so hello world, then 0DH, then 0AH, then 0, I don't have to do the CRLF anymore because it's part of the string. I generally recommend against this because now it's hard-coded, it's baked into the string, and if I ever wanted to just print hello world without it, I am stuck. There's nothing I can do to accomplish that. So, but otherwise, if that's what you want, then you just do the same. Put the offset of the pointer, the offset of the array into the EDX register and give the write string a call. Okay, so display an unsigned integer value in binary, decimal, then hex, each on its own line. We didn't touch all of these functions in my previous discussion, but nothing to it. And as you can see here, if I take whatever my value, which is 35, and you could put 35 directly in if you wanted to, and then I call write binary. We did do that one earlier. CRLF to go to the next line, so it's, you know, everything is nicely formatted. Write it in decimal format, so there's 35. Write it in hex format, that's 32 plus 3, 35. You see what's going on here. Everybody's happy because everything's been printed and I've followed the example as I'm supposed to. Okay, so 2 more examples, and we have one of them we've already kind of done. So this one starts out simple. We haven't covered this. I haven't talked about this in this video. So input a string from the user. Like, okay, I have to use read string, so we can use something like this. And so I already wrote some code over here just to make it work here. So I say, okay, input a string from the user. So I need a string to store the data once the user types in stuff. And so I supply an 80-byte character array, uninitialized right off the start. I'm just going to call it n. Okay, and then what I'm going to do here is I'm going to push and put the offset, the pointer of this thing, into the EDX register. That's one of the requirements. Excuse me, it must be 11 o'clock. All right, so and put the pointer into EDX register, and then you also have to supply how many bytes of storage can I put, or like how many characters should I store, because you don't have unlimited data, right? And so you see here length of n minus 1, and that's because the -1 comes from the fact that one of those bytes has to be the null terminating character, the 0. So I'm only allowed 79 bytes of actual real stuff before I can hit that null terminating 0. Otherwise, I've basically outstepped the bounds of the array, which is never a good thing. And once I've set up these 2 registers, then I can call read string, and then I can do whatever I need to do with it. So I can say here's my name, Bradley Sward. And so it's just going to pair it back, and there it goes. It prints out whatever I've done before. So it says, okay, put in EDX, put in ECX, call read string, and then call the, basically whatever was put into there, bring it back, put it in, call, and do everything else we've done before. So again, the only big deal is, what do I do if I put more than 80 characters in here? So this is definitely more than 80 characters. I hit enter, and you see it only prints out, and in this case, it would only print out 79 of them, because, of course, the fact that the null terminating character is one of them. That little 0 is kind of right there, but kind of not. You never get to see it. So that's all I need to do, right? That's your basic string cin, if you want to think about it. Because we have our basic character and byte and word and that kind of stuff. We have those read functions and we have those write functions. So we have that cin cout behavior. Okay, so example 5, example 6. Generate and display a random number in the range 1 to 100, do it 20 times. We've already talked about it, so so I guess example 5, example 6, whatever, just go with it. And so we've already discussed this, so I'm not going to rewrite this, but I can call randomize up front, so every time I run my program, everything randomizes, so it's different values every time. Set 20 to my ECX register and put my loop down here. My loop, if you haven't seen it, other videos, you can see how the loop works. So move 100 into the EAX register, call random range, that gets me values between 0 and 99 randomly, increment it so that I've shifted everything over, so everything's in the range 1 to 100, print it out, do a carriage return line feed, do it again, do it again, do it again. So we've already discussed it, so this code works perfectly. And so the last step here is display a null terminated string with yellow characters on a blue background. We've already kind of covered this as well. So let's just say, okay, let's do what we already have here. Let's just use this and just change the color. So before I call the write string, I just have to move into the EAX register. Like, okay, so I want the background to be blue, so the blue times 16, and I want the foreground to be yellow. And then I can call set text color before I do any of the other stuff. And so I enter my data, and it prints out, and now you can see it prints out everything. with the blue background and the yellow foreground. So that's very similar to what you see here. So it's just a little reversed. I mean, of course, the order of operations are going to be the same. Yellow plus blue times 16, set text color, put something into the EDX register to print. So we've already done more than what this is, but this is the simple and refined, the simplest way of doing things that we can show to do all of that stuff. And that pretty much covers the basics of getting going. Of course, things are going to get much more complex as we move into bigger and better data structures and bigger and better things. But as always, if you have any questions, swardb@cod.edu is a great way to get a hold of me. Put a comment here on YouTube. I'll get back to you as soon as I can. So thanks for sticking this out with me. Have a great day, everybody. See you next time.